Hello, this is Tony Nichols, founder and CTO of Great Ideas on Demand. And in this video on enterprise architecture, we're going to be having a look at incoming data flows. And we're going to be using examples using Microsoft.NET Blazor as your Great Ideas Trellis Spark as a foundation. And we're also going to be looking at a ton of T-SQL. So this video is going to try and answer a few important questions. The first of which is obviously, why do we need to import data in the first place? We're then going to have a look at the different data import scenarios that are common in most applications. And we're also going to answer the question about why do we want to decouple incoming bulk data from the rest of our database, and particularly our user experience. We're going to do a couple of demos, first one of which we're going to be looking at auto-generating tables and T-SQL store procedures to help with bulk data migration. And we're also then going to do a separate demo on how do we actually control the bulk data import process on an ongoing basis. And finally, we'll just have a look and summarize why should we use this approach in the first place. Okay, so let's start by answering the first of those questions. Why do we need to import data in the first place? Well, quite obviously, not all of the data that we're going to need to be able to display or process will be inside our data at rest systems of record. So there are two options. Essentially, we can retrieve the data as needed from external systems. To do that, we would use real-time or point-to-point integrations, where when we need the data, we would go to the external system, we would hope that external system would be available, and then we would pull the data we need as we need it. The other alternative is that we need to copy the data into our own system of record, and we have a number of mechanisms to do that. We can do a bulk load, or we could execute some form of batch or extract transform load ETL type process. So if we're going to copy the data, then there are two other things that we need to think about. Are we going to allow changes to that data? And if we are going to allow changes, then do we need to synchronize the changes that we make to the data with external systems? So essentially, we're looking at, are we synchronizing the data one way? So from the external system to our system, from our system to the external system, or are we going to do bidirectional synchronization, where if we make a change in our system, it's reflected in the external system and vice versa? There are a couple of different things to really think about as we build these solutions, and we'll be doing a complete video on data synchronization and using the Trellis Spark framework as an entity synchronization layer, or an ESL, that will allow for bidirectional synchronization of data between one or more systems. So given that we do need to import data, what are the different import scenarios? Well, there's two basic cases to consider. The first of which is real-time integrations. So typically this is done on a record basis using some sort of API or messaging technology. So I may, for example, have a REST API that I would call on an external vendor that would say pull down information about a vehicle or an order or an invoice. Or I may receive messages from an external system telling me that they've got a new policy or that they've registered a new vehicle. So typically a real-time integration is done on a record per record basis, and it's essentially going to use an API or some processing or workflow that's going to basically get that record, that will validate that record as it is received, and then store the information in the database. And this happens, as we say, real time. Okay, so within seconds of the data being available in the external system, or that data being needed to export it to an external system. So real-time integrations, essentially it's a case of workflow. And we'll deal with real-time integration in its own little video. What we're really going to focus on today is the second major case, the bulk data import. So essentially what we're looking at here is that many records, so typically hundreds or thousands or tens of thousands of records, are received at the same time and processed together as a batch. So essentially what we're looking at here is it could be as we load the data in the first case. So we have a new system, its database is empty, and I need to do an initial data migration. This is a common use case that pretty much all application developers will come across at least once or twice in their careers. You could be loading millions, tens of millions, hundreds of millions of records all at the same time in this particular approach. The next case that we do need to consider that's also essentially bulk data import is large batch files that are sent by external systems, either on demand or on a scheduled basis. So for example, it's very common that maybe every hour I will receive a batch file with 1,000 new insurance policies in it, or every 24 hours I would receive a batch file with payroll data in it for 10,000 employees. So batch files, typically on demand or scheduled, scheduling every hour, every day, every week, whatever. And what we're looking at doing is saying, okay, we're getting lots and lots of records, all of the same format, and then we're going to push those into the database as a batch. So when we're looking at the initial data migration capability. Typically, a developer is going to do this once or twice in their lifetime, right? So if I'm working on a particular system, I build that system, I do the data migration, and maybe that system runs for 10, 15 years. So I might only do a data migration 2 or 3 or 4 times in my career. So when we're looking at that sort of frequency, every single data migration looks unique. What I did 10 years ago versus what I might do this year for a particular data migration may look very different. And particularly since the data migrations are very specific to the application, to the tables we're loading, this is what the old system looks like, this is what the new system looks like. This is extremely custom, tailored. It's always a unique experience where you have an initial starting set of conditions and we need to migrate with these rules, and here is the endpoint. And so for a lot of developers, this whole data migration process looks to be unique. They look at this pattern and say, well, okay, I've got to build this whole thing from scratch. But those of us that are constantly involved in data migrations understand that as we do this many, many, many times, we see architectural patterns. And as we see those patterns, then we look for processes that can be automated, and then we add minor customizations around that automation. So one of the things that we're going to be looking at in this video, particularly and in the demonstrations, is what are the patterns that are related to these data migrations? How can we actually then automate those data migrations so that we can focus on the unique business rules of a particular migration, rather than having to basically invent the whole thing from scratch every single time? So one pattern that we see over and over and over again is the need that we need to be able to decouple the incoming bulk data from the data that's currently in the database and is understood to be good, high quality data that's being used live by our user experiences. So one thing that we want to do is, as we've got bulk data coming into our system, we want to decouple it from that user experience data so that we have a chance to validate that information and load it in a way that doesn't pause the database, doesn't actually freeze the user experience for all of our users. So the way we do that is we use a migration table within the security context as a way of actually receiving that bulk data. So the bulk data doesn't immediately go into our core database. It doesn't immediately basically go into our user experience records. It goes into a temporary migration table. And this is great because what this enables us to do is a whole bunch of processing on that data before we accept it as valid, real data that we need to be able to expose through our user experience. So the first thing that we want to do is we're going to use basically a SQL table so that we can do some basic field type validation as the rows are loaded. So for example, if I know one particular column in that database happens to contain a date, I can use a date column and I can make sure that any rows put into that migration table, that column, the value is a date. Or if I want a number, then it's an integer or it's a float. So the first thing we're going to do is build a migration table with a bunch of columns that are all typed, that will allow us to take the data from the external data source, copy it into the migration table, and validate that all of the columns have got the right types. And because that is a completely separate and distinct migration table, completely separate from anything else that's going on in our data agnostic services, the population and basic testing of type validation in that table is not in any way going to impact our user experience or performance. So first level of decoupling, temporary migration table. Given that we now have our bulk data in our migration table, then what we want to do is we want to really look at this data in a lot more detail. So essentially what we're going to do is we're going to create a set of batch T-SQL store procedures that will validate and process that data. So there's a whole bunch of things that potentially we want those T-SQL store procedures to do. First and foremost, let's actually check the business rules. So for example, if we say that all dates must be in the past, let's have part of that T-SQL running through that data that we've got in that migration table and actually check that all of the dates in this particular column are dates in the past. And any dates that are dates in the future, well, let's flag that row as invalid. Okay, so first and foremost, check the business rules. The next thing we're going to want to do is we're going to want to map the primary and foreign keys from the external system to our system of record. So in this particular case, then, we may have, say, a set of customer records. And in Trellis Spark, we use instance GUIDs to act as the primary key for all of our customer records. So every customer record is going to have its own unique instance GUID. But in the external system, maybe those customer records are indexed with a primary key that's an integer or some weird letter alphanumeric combination. So one thing that we're going to want to be able to do is map the primary and foreign keys of the external system to our Trellis Spark system of record. So essentially, we're going to need some sort of mapping that basically says that this customer I brought over from my external system, customer number 123, whose name is ABC, I need to be able to map that to customer ABC in the Trellis Spark system with this GUID. So we need to be able to map those primary and foreign keys. Then what we need to do is say, well, okay, you know what? Our external system may have had all of this stuff in a spreadsheet. It may be in a relational table. It may even have been some sort of JSON document storage. But what I need to be able to do is I need to be able to take whatever the incoming data is and set that up as an XML fragment so that I can load that information. So if you remember, within our Trellis Spark database, our data agnostic service, the storage format is an XML fragment. So I need to be able to take whatever information I've got available from my migration table, I need to be able to convert each one of those rows into its own equivalent XML fragment so I can then load that into my data agnostic storage. And then finally, once I've checked the business rules, once I've mapped my primary and foreign keys, once I've converted it to XML, then I want to make sure that I upload the valid data into the system of record. So I'm going to basically go through and say, well, okay, you know, I downloaded 10,000 rows into this migration table. I've applied my business rules, I've done my mappings, I've done my formatting, and maybe I've rejected 1,000 of those records because for one reason or another they're invalid. I now have 9,000 records I want to upload into my Trellis Spark data agnostic system of record. So what I want to be able to do as part of that upload process is to be able to track the correlation of those 9,000 records I'm uploading and the 1,000 records that I didn't load and flag any errors. So I may have basically introduced a whole bunch of errors in the 1,000 records that I did as I was working through my validate and process the data. And now I've basically tried to load the remaining 9,000 records. Maybe I got another 50 fails. So what I want to be able to do is say, well, okay, here is the correlation ID on the original 10,000 records. Here are the errors that occurred on the first 1,000 records and the errors in terms of trying to actually load them on the next 50 records. And here's all of the records that actually went through correctly. So ideally, I want some sort of process that allows me to correlate those initial records that came in from the batch and to be able to identify any errors that occurred and ideally to be able to then fix those errors and resubmit the failed records into the database. So now let's look at our first demonstration in this video. What we're going to look at is a way of being able to take from our data agnostic services the form definitions that define the concepts that we will want to be able to import. So for example, if I have a concept of customers, I will have a form definition for that concept. And that form definition will tell me all of the data fields I'm expecting to see in customers. So I can use that form definition to auto-generate my migration tables and to get a good part of the T-SQL stored procedures that I will need to actually validate and load those customer records. So let's have a look at a demonstration of how we would go about that. So in this first demonstration, what we're going to look at is the underlying code generation technology that enables us to create a migration table for a concept and also create the data builder stored procedure that will be used to process the data that we want to migrate and load into our database. So let's get started. In Trellis Spark, obviously, we build everything using .NET 6+, and here is our REST API service. I've already put some breakpoints in here that we're going to have a look at when we review how the code builder is working in the background. So let's kick this off now. As you can see, our REST API has now started. So now let's kick off our user experience. So we'll just put this out of the way, move this out of the way, and then engage our Blazor WASM user experience. So let's quickly log in and navigate into our server owner workspace. So server owner is the workspace that we always use when we're building or managing data models. Now, the example we're going to use today for our migration is the customer information. So what I'm going to do is I'm going to navigate to the example customer and client management functionality that we provide as part of our demo workspaces. And we're going to be interested in having a look at our customer form. So at this point in the development process, we're making the working assumption that business analysts have worked with the business to define what a customer is. So let's have a look at an example customer. So if I go to customer services, I can go and have a look at a test customer. And here on my test customer, I can see I'm storing the legal name of the customer, the type of the customer, the ID, and so on. So at some point, the business has been consulted, the business analyst has been engaged, and they have built a data model that says, this is what a customer looks like. I want overview information, I want contract information, orders, and so on. So this work has already been done. We have already built a data model for a customer. Now, if I go and have a look at my history, I can navigate to the form definition for the customer. And those fields that we were just looking at on the customer record are represented here. So I can see the legal name of the customer, the type of the customer, the ID, and so on. So all of this work has already been done. Okay, your business has been consulted, the data model has been created. Now what we need to be able to do is migrate information into this data model from any potential source. So what we're going to do now is we're going to run through the data migration creation process. So here you see we have a tab called Data Migration, and there are a few simple fields that we need to fill in. So the first question is, do we even need a migration table? Well, in this case, yes, I do want a migration table. And then I'm going to ask the question, well, what is the sequence number of this migration? So how do we determine migration sequence numbers? Well, if you go to the Trellis Spark Academy and you look at the processes around this, you'll see that we have very extensive documentation on data migration that I'm not going to bother reading through the whole document here in this video. But to answer this very specific question about what migration sequence numbers are, let's have a look at this portion of the documentation. So you can see, as far as the customer client management information is concerned, there may be, say, 4 things that I'm going to migrate. I might need to migrate customer information about products, clients, and contracts. And I need to order the migration so that everything that's built is built in an appropriate hierarchy. So in this particular case, the customers are created at the workspace level. So I can assign them a sequence number or a hierarchy number of 1. Okay, so the customer is a child of the workspace, and so its sequence number is 1. So I need to load that before I load any of its children. So product, client, and contract are all child objects of customer. So logically, I could assign all of these a sequence number of 2. And certainly in the case of product and client, that's absolutely the case. There are no other dependencies on the product and client other than their parent customer already exists. But if we look at the contract, we can see that there are dependencies on the contract to the client and the product. So if I try to load a contract before the associated products and clients weren't available, then the contract load would fail. So what I need to do is assign a sequence number of 3 to the contract, because as well as depending directly on the parent, it also indirectly references the products and the clients with sequence number 2. So let's go back and assign a migration sequence number of 1. Now, the next thing we need to assign is the parent concept. So which concept is this a child of? In this case, we've already discussed that the customer has no parent. The parent is essentially the workspace itself. But if we were looking at, say, for example, the client and the migration sequence number was 2, then the parent concept of the client would be the customer. So we would select customer like this. Okay. Given that we are actually migrating customer information and the migration sequence number is 1, we can just leave this empty. Now, finally, we need a default status for new customer information being loaded into the system, and we're going to set that default status as prospect. Okay, and that's it. That's all we need to set up. Okay, we've already defined what a customer is, what the tabs are, what the permissions are, what the role play. All of the user experience is already defined. And so to actually execute this last step of figuring out the data migration, this is all we need to actually build the generic code generation version of the scripts to migrate the data into a temporary table, and then from there to process that migrated data into the actual data agnostic record storage. So once I've set these values here, I can save this information. And now I can go back and execute the generate data migration script. So I'm going to generate the migration script now, and you'll see this now flows into our stored procedures and our migration. And you can see this has now made a call into our REST API to actually generate the migration table. Now, code generation is not magic. It is inherently a simple process of constructing a script file. So it's just a simple SQL file that we're going to execute against our database. So essentially what's happening as we execute the migration script process is all we're really doing is going into our data model and then generating a SQL script that we will look at in a little bit more detail later. And all this SQL script generation process is doing is it is appending lines into a SQL file that we're then going to be able to execute. So here, for example, you can see that we're creating a table and we have some example data that we're going to pull out in a minute for the customer. So here you can see that the table that we're migrating has some standard columns that we're going to use as part of the process. And then as we work through the standard columns, you'll see that we're then actually looking through all of the different elements within the customer data set to actually figure out what is the element, what is its data type, how am I going to migrate its data. So essentially that's what this code here is doing. It's going back, it's trying to figure out what is this element. It's an address, it's a contact, it's an ID, it's a date, and how are we going to use that. Now here we're just doing the final part of this that we'll have a look at in a minute in the underlying T-SQL, but you can see essentially that what we're doing is we are now adding a primary key to our migration table. That's basically the instance GUID of the new records that we're going to insert, and we're also going to create a non-clustered index on cycle and iteration GUID that we're going to use in the demonstration later to actually control the migration process of this data. Now, the other thing that we need to build as part of our automated code generation process is a data build as a stored procedure. And what this is going to do is, again, it's very, very simple. We are creating a text file, or we're appending to our text file a T-SQL stored procedure definition based on the information that we're pulling from our data model. And again, we put some nice helpful commentary in here, and we're going through a process of actually dropping and creating the new function. We have a standard set of parameters so that all of these procedures are called using essentially the same signature from the execution of the workflow, and they're all basically following the same pattern. So we're applying a common standard to saying, well, okay, you know what, before we even start the migration, is there a migration table there? If there's no migration table, we can just abort, we're finished. If there is a migration, now what we're going to do is we're going to work through the process of actually executing the migration. And again, we'll review this T-SQL in a minute. But for now, the point I want to make is that the code generation technology is very simply building these standard mechanisms and interfaces that allow us to take the data from any data source to put it into a common format based on what our new system is expecting to be able to display or process, and that to create the T-SQL, we can use that data definition to create the SQL scripts. So if we just continue running this through the migration processing, what we'll see at the end of the process is that we now have a migration script attached to our customer object, and we can open this up in SQL Server. So I'm going to download this migration script and open it in SQL Server. Okay, so here is my migration script. So this should be familiar, right? This is the code that we added as we worked through the process of generating the script. So you can see here we are trying to build something for our ZCM customer. We're creating a migration table for our ZCM customer. Here are all of the common fields that we need to be able to process customer information into the database. Here we have a set of fields that were actually on the customer that we want to migrate. We have a note here. So anywhere where you as a developer might need to do some custom coding, we've basically tagged a comment above it. In this particular case, the customer IDs are being set up as a numbered sequence. So as a developer, you would need to put some time or thought process in here to make sure that your customer IDs are being numbered appropriately. And then here, we saw in the breakpoint that we're now creating the primary key on this new migration table, and the primary key is always the instance GUID of the record we want to insert. And we're also creating a non-clustered index using the cycle GUID and the iteration GUID. And as you'll see in the automation part of the demonstration in a minute, that this is basically used to actually control the processing of the information. So if we're dealing with bulk data, you might not want to be trying to do this all at once. If I've got like 1,000,000 rows of customer information, I'm trying to import that into a live database, I might want to do that 100, 1,000 rows at a time. So the cycle GUID and iteration GUID allows us to actually control that process a little better. Now, we also provide a comment version of the standard insert into the ZCM customer table. So if you want to migrate data into this table, then this insert statement gives you the actual template for the top part of your insert. And obviously you'd replace the values with your select statement to actually get the data from the source into the migration table. And what we'll be looking at in subsequent videos is the other part of this process. So this process is just dealing with, I've got my data into my migration table. How am I going to process that data into my data agnostic storage? So that's half of the migration story, if you like. The other half of the migration story is, how do I get the data into my migration table in the first place? And so can we look at using code generation to pull information out of, let's say, an Excel spreadsheet or another SQL database or a MySQL database or some other repository of information? How do I get the data from that legacy system into my migration table in the first place so that I can now process it from the migration table into the data agnostic storage? So this is essentially a template that we will use in a minute to actually insert data into our migration table, see how that goes. Now, the next part of the script that we were looking at was this data builder, the stored procedure that's actually going to process the information from the migration table. It's going to execute it as a bunch of cycles, and it's going to load that information into the data agnostic storage. And what you'll see as we go through the migration process is that some values are hard coded. So things like, say, for example, the concept GUID of our customer, we've pulled that from the data definition of the customer. So the concept GUID of a new customer is going to be this concept GUID here, the 3F67 concept GUID. So we know what that concept GUID will be, and that's how we're pulling that concept GUID out of the system. As we discussed when we looked at the code generator, the first thing to do is check to see whether or not, when I actually execute this stored procedure, whether or not the migration table exists or not. If the migration table does not exist, then I don't need to do anything. If the migration table does exist, then I'm going to want to execute the processing. And you can see here we're defaulting the iteration size, so we'll default 1,000 records at a time and so on. So all of these are basically being pulled from the working data set, and the data definition of what a customer is actually contributing to these values here. So here, for example, the default status is being set to prospect. The workspace GUID of our server owner workspace is this workspace GUID here. So one of the things that as a developer that you're going to want to do is just validate that these defaults are what you're expecting and that you are happy with the way that the processing is going to execute. So down here, we're making a decision on the parent-child hierarchy. So if the parent concept GUID is not null, so this may be, say, clients going into customers, then we need to basically update and find the parent concept GUID based on the old primary key of the source data. In this particular case, we've decided that we're importing customers, so the parent GUID is going to be the workspace GUID, and the hierarchy is simply the workspace hierarchy. So essentially what we're doing is we're updating that customer data set to actually define the parent and hierarchy fields based on our knowledge of what a customer is and where it sits in the hierarchy. The second step of the process is to actually run through any fields that we can actually pre-process at this point. And essentially what we're doing here is we're just working through and seeing what fields exist in the customer record. Is there any processing that we need to do to start off with? So are we able to map any items or subforms or any other concepts for cross-references? So for example, if we were thinking about, say, that contract that we were looking that had a link to a client or a product, this is where we'd actually want to try and map those client and product references to the contract information. So in this particular case, there's not really much we're doing other than mapping subform information. And then once we've finished the data pre-processing, then this piece of code here is where we actually start going through the iterations. So as we actually execute this as part of the automated workflow, this is going to break down all of the records that were identified as part of this cycle in the SQL that was executed earlier. And it's going to break that up into the different iterations that we're going to basically execute. So essentially, there might be millions of rows of data in here. We've set the iteration size to say 1,000. So what this piece of code is doing is it's going through those millions of rows and assigning 1,000 of them at a time to a single iteration, and then it's going to process only those rows within that iteration. Now at this point, what we want to do is we want to convert the information that we've already pre-processed into the XML that we want to actually put into our data agnostic record storage. So essentially what we're doing here is we're going through and we're going to update the instance data field in the customer record as to an XML variation that basically takes the information out of each of the individual rows in the customer table and converts that into an XML format. So essentially that's what this update statement is doing here. Once we've done that, we're then going to go and use our Great Ideas Instance Name Builder to actually go through the information off the migration table to create the instance name of this particular customer. And now we're at the point where we're taking the information that's already been completely processed out of our migration table, and we're inserting this into the data agnostic record storage, into the instances table itself. So essentially that is what this select statement is doing. So these are all fields that we've actually set up as part of running through the process. And what we're doing is we're doing a check to make sure that it was assigned an instance GUID, that we figured out what the name is, and we know where the hierarchy, where the parent is, and that we've actually successfully converted the instance data, and it's part of this iteration. So if we had 1 million records of customer information, we've identified 1,000 records that we wanted to convert. We've filled in all of the blanks. The instance GUID is filled in when the table is created. The instance name you've just seen being calculated. Hierarchy and parent GUID are basically being keyed as part of that earlier select statement, and the instance data is part of that XML build that we just saw. And then we're just going to check to see whether or not there are any other rows in the cycle that we haven't already processed. And if there are, then we're going to go round the cycle again. And then at the end of the process, we know which rows were successfully moved, which rows failed, and we're going to basically add data into a report table to tell us what worked and what didn't work. So again, this is part of the last part of the automation process that we'll look at in the next demonstration to see how this is actually be executing. So what we can do is we can now execute this T-SQL, and all this is going to do is this is now going to create my migration table and my migration script. So if I go and have a look in my Object Explorer for this database and I go to a refresh, I can open up my list of tables, and I am going to be able to find a migration table for ZCM customer. So if I have a look at that, here are our standard columns that are basically controlling the migration process. Here are the data columns that contain the information that we're going to load. And if I scroll down here and open up my stored procedures, you can see I've now got a data builder, ZCM customer, that we can have a look at and modify as necessary. So as a developer, we won't get this 100% right. There's no way that the code generation is going to pick everything up, but at least what the code generation should be able to do is identify any steps where you're going to need to actually put some thought into the process around how do we actually need to make changes as a developer to implement specific business rules that are not obvious from the data model. So essentially, as a developer, you might be coming in here and making some tweaks and changes to the stored procedure, but most of the functionality, for example, the iteration type processing, a lot of the T-SQL that you're going to need to actually do the conversion from the rows from the migration table into the XML has already been done for you. And anything that you might want to look at in terms of customization is going to be flagged with some nice big obvious comments. So you can actually come in here and you can say, well, okay, you know what, this customer ID field, it's a counter. I need to make sure that all of the IDs associated with this customer as they come on are not conflicting with counters that already exist. So I might want to put some thought into this particular piece of code here to see whether or not I need to do something that's not part of the generic solution here. So we basically provide you with the generic and then give you a flag on here that says, as a developer, have a think about this particular data item here. Is there something specific that you need to do here to make this work better than the generic default? Okay, so as you can see, all of this has been generated, and we now have a pattern that is consistent in the way we have created the migration table, in the way that we've created the stored procedures that's going to process that migration table, that's going to figure out where does this new record sit within the overall parent-child hierarchy. What's the concept of this new type of data we're importing? What's the default status? Or can I override the default status with maybe the status of a record coming into the system? But as a developer, most of what you need is now here. You're probably 90%, 95% of the code that you're going to need to do the migration from the migration table into the data agnostic storage has already been created for you in this script. And we've called out with some very simple comments the areas within the script that you're going to need to do some work for. So all that being said, that's the code generation part of the process outlined at a high level. And now what we're going to do is we're going to do a separate demonstration where we're going to look at how this is actually being set up and executed in practice. So given that we now have a mechanism for auto-generating the migration table and the validation store procedures, we also want some workflow or process that allows us to control the bulk data import. So let's have a demonstration of how the Trellis Spark solution is used to actually control that migration process and report the results back to the user. So in this second presentation, what we're going to look at is using the code generation results from the first demonstration to actually load a set of demonstration customers from our Great Ideas workspaces into my dev database. So let's see how we'd go through that process now. So I have started by making a copy of the insert statement for the migration table into a separate query editor. And what I've done is I've basically come in here and said, I want to use as the source for this migration table all of the rows that are in my current demonstration database in my ZCM customers. So all I'm doing here is grabbing some test data from a different database and loading it into my migration table ready for execution. So let's pull that. And we can have a look and see what we actually got. So we've actually pulled 22 rows of test data. And to make sure that they are distinct from the records that already exist in my dev database, I've prefixed all of the counters with 3 nines. So if I have a look at the customers that currently exist in my development test database, you can see I've got 16 records in here, and that those records all have a customer ID which is prefixed with zeros. Okay, so very clearly, the data that's coming in from my demo workspace all has customer IDs prefixed with 3 nines. The data that's already in my dev database is prefixed with zeros. And this is important because what I want to show you is that the data that already exists there is not being overwritten, it's being added to. So this is not just useful for migration, this is useful for ongoing import of customer information over time. So I might get a new list of customers from a different solution maybe every 24 hours. So this is essentially enabling me to incrementally add new customers into my database on an ongoing basis. Okay, so I've got 16 rows of data that already exist. I've got 22 rows of data that I'm going to load up. So by the time I'm finished, I should have a total of 38 rows of data in my dev database. So let's see what happens and how we go about this process. So we talked about the fact that we are going to have a controlled migration, right? We're not doing all of this through SQL. I've set up the code generation in SQL for sure, but I'm actually running it for my user experience. Now, in this particular case, customers are in my customer and client management functionality. So I'm going to go into my customer and client functionality. If I had a look at the forms and had a look at customer, this is where that customer data migration information was set up in the previous demonstration. So you can see that, yes, I do need to migrate it. Its sequence number is 1, and I've basically generated and loaded a migration script and said that the default status of all my customers is going to be prospect. So this is how I set my customer up in the first place. So let's go back and say, well, okay, great. Now I want to run controlled migrations for customer and client management functionality. So I'm going to go to the data migration of the functionality, and I'm going to create a new migration run. So each run basically corresponds to one sequence number. So if I had, say, 5 tables with sequence number 1, then this migration run will pull all of those 5 tables. In this particular case, I've only migrated 1 table. So I'm going to say initial test of customer. And so if I now execute this migration, what you'll see is I'm coming to this code here in my user experience REST API. And essentially what this is going to do is this is going to basically interrogate the migration information that's set up for all of the functionality and all of the concepts inside that functionality with sequence number 1. And then what it's going to do is it's going to go through here and say for all of the tables where the sequence number was set to 1, so all of the concepts that I need to migrate, now go and execute the data builder stored procedure. So this is the stored procedure that we auto-generated in the previous demonstration. You can see this is our data builder ZCM customer. And you can see that this thing runs very quickly because, hey, it's only got 22 rows in, right? It'll take a bit longer if we've got thousands and millions of rows. We're only doing a small data set so that we're not spending a lot of time on the migration. Now, once the migration has completed, and we've completed the migration run, then we're going to update the migration run status and return the result set. So at this point, if we just free run it, you can see here, this is the date time of the migration, that it was completed successfully, that it was executed by me. Here is the cycle GUID. Now this cycle GUID is useful because we can use this to roll back our migration if we need to. And you can see that as far as the migration is concerned, it successfully imported 22 rows. So this is good, right? So let's go and have a look and verify that it's done what it said it was going to do. So what you can see here is I'm just going to save my migration key here. Let's get rid of this. And now if we go and have a look here, we can see we have 22 rows, and all of these used to be null, but you can now see that they've been completed correctly. So the parent GUID is the workspace GUID. Here's the instance name, the hierarchy. I've got an XML representation of the data. The cycle GUID here corresponds to the correlation GUIDs that we're going to see on the instances table when we look at the records that were imported. Here, the old primary key is the instance GUID from our Great Ideas demo workspace, and you can see that we've got new instance GUIDs for these records after we've migrated them. And then here we've got the data that's all come across correctly, and just superficial glance at the data, it looks right, looks like we've got all of the values correct, except, oh no, right, so here, right, this subform GUID, this should have been mapped, right? I mean, essentially I've got a subform called basic and it should have been mapped to the right thing. If I go and have a look in my ZCM view here, you can see, for example, I've got 38 rows, so I've got the right amount of data. But if I go over here, you can see that these are the rows that we've just imported, and the values here are coming back as null. But it should have come in with this value here, this 48 number. Okay, so clearly there's a problem. All right. Now, if I go and have a look here with my correlation GUID as a cycle GUID, you can see I've got 23 rows, and I'll explain where the extra row comes from in a minute. But essentially what we've got basically is that we've got a problem. The data we've just migrated is incorrect. So I want to be able to take this data out without breaking anything, right? So what I can do here is I can come in here and I can basically just delete from the instance table all of the records with the same correlation ID. Now, we said we had 23 rows here, right? And there's a problem, right? Because there's only 22 rows of data. But what we've got is that this correlation GUID has also been tagged onto the record that tells us how many rows were actually imported. So you can see here that the concept GUID on this one is slightly different. So what I'm going to do is I'm going to copy this concept GUID here, and I'm going to modify this and say where concept GUID not equal to this, and the correlation GUID is that. So if I execute this now, you'll see I take out 22 rows, and I should have exactly one row left here, which is the thing that told me here that we migrated 22 without any errors. So it's always a good idea just to keep that last result, right? Okay, so let's go in and try and figure out what's gone wrong. So the problem that we had here when we look at this customer information was that if I have a look at the customer data, I failed to map this subform GUID. Okay, so if the subform GUID is correctly mapped, I should be expecting to see values here, not nulls. So that tells me immediately that I need to go and have a look and customize the default migration procedure. So here's the migration procedure, and I'm looking for an error in the subform fields. Okay, so essentially I know that my problem exists somewhere here. Now I know that my basic subform template is a subform template, not a subform definition, so my problem is likely to be with this select statement. So let's have a look at what this statement's returning, and I can see immediately now what my problem is here. Right? My subform in the migration data, the value is basic. Here you can see that the value coming back has been prefixed with the subform type name. Okay, and that's going to cause me a problem because that's going to fail to do the mapping, which is why I'm not seeing a value in here. So what I'm going to do is I'm going to basically make a change here and say that what I really want to be able to see here is I'm going to be looking for the name column, and I want to report that as the instance name. So if I look at this now, you'll see I've got the names down here, and down here I've got basic, and it's mapping to whatever basic's supposed to be mapping to. Okay, so this is good, right? We're in a better place. So let's take this and execute that change. And now what we will do is we will clean out our data and try again. So I'm going to truncate my data here. I'm going to reinsert my 22 rows here. I'm going to check that this is now back to nulls, and I have 22 rows, and this is all null. I'm going to check that my customer is back down to 16 rows. Okay, so let's go back and execute this again. So once it's done, I'm going to add a new migration run. Again, I'm executing sequence 1, berg fix for subform mapping, and we'll execute the migration again. Don't need to step through this twice. So again, I've got a new cycle GUID, and it thinks it's done 22 rows, which is good news. So let's change our correlation GUIDs here and here. So if we have a look at our migration data set now, see how all our nulls have been completely filled in correctly. And here you can see that my subform GUID for basic has been mapped. So this mapping looks good. So I've fixed the mapping here. I go and have a look at my ZCM view in my customer data. You see I've got 38 rows, which is what I was expecting to see. And you can see now that all of the basic columns have got the correct GUIDs mapped onto them. So at this point, all of the data has come across. I've got a whole bunch of 99 prefix data. So this looks good, and it's all been loaded into my workspace. So at this point, I can go back, and if I go to customer services and pull a list of customers, here is the list of customers that were in there before the migration. And if I now refresh this list, you can see I've now got a whole bunch of 99 prefix data coming through from my Great Ideas demo workspace. And you can see that everything basically in here has been set up correctly. So from this perspective, what you can see is that the migration functionality is very simple and generic in concept. By default, we can use our user experience to generate our default migration scripts. We can then create a migration table that's going to use that script to actually convert the data and move it into our instances table. If we have a look at our migration process, you can see that the migration process itself is very simple. From a control perspective, is that essentially what we're just going to do is execute one of these data migration runs. And you can see this is basically just a call to a REST API. So here, as part of, let's say, an initial data migration strategy where I'm actually building and testing, I'm just going to run these things using a manual user experience. And even, for example, for a first load of a data migration into an application, I might still go through the manual process just to make sure that everything is actually running the way we're expecting it to run. Where we've identified a bug, we've been able to go into the migration script and just fix up the migration script, and that's been a quick and simple process. So you can see you get like 95% plus of the migration for you from your user experience definition and the code generation. You then just need to focus on those areas of the migration that are incorrect and not actually returning the correct results. And then here we've got a nice simple user experience for actually testing the migration properly and then actually executing maybe our initial data migration into the solution. Now the obvious extensions then coming, well, what about scheduled migration runs and ad hoc? So again, for an ad hoc, I just want to put the migration data into the migration table and then run the migration script over it to actually pull the data across and load it into the database. If I'm doing this on a regular basis, like every day or every hour, then obviously what I can do is I can then add the call to that migration run as a part of a background window service or as a scheduled job. So I've got lots of different ways of actually scheduling those migration runs on an ongoing basis and then making sure that on a record-to-record basis, I've got very accurate mappings of what data was put into the migration table. How was that data processed? Was it processed successfully or did it fail? When we ran the migration, how many records did we import? And if I need to rewind that migration, as you can see from the demonstration, it's very easy to put the cycle GUID in as correlation and then just take that data straight back out again. So this gives us tremendous control and functionality in actually pulling data into the solution and then being able to do that as part of an initial load of that solution or as an ongoing refresh of information coming from other data sources. And in the background, we also have a permanent record of what data did we attempt to migrate. So what did the migration data look like? So if any of this information failed, if any of the mappings were invalid, I have a hard record of what I thought I was attempting to migrate. And from the correlation GUIDs, the cycle GUIDs, when did I attempt to migrate it? So what cycle was it in? What iteration of that cycle did we attempt? Do I need to roll back a whole iteration or a whole cycle all at once and pull that information cleanly out of the database? And I can absolutely do that. So we have tremendous flexibility. There's a lot of commonality. If I need to go back into the code-generated function and tweak something, as you can see, it's very easy to identify and then to tweak the migration code so that we actually fix or repair any issues with mappings. This gives us a very powerful tool for importing bulk data, for maintaining records of where that data's come from and when it was loaded and who loaded it and whether or not there was a problem with the migration, and very easy way to recover from those issues. So to round out this video, let's summarize why we should use this approach. So the reality is that most of us at some point as application developers are going to have to build a mechanism for importing bulk data. So either you can start from scratch every single time, or you can basically work off an existing pattern. Now, one thing that we have found when we start talking to people about adopting data agnostic record services is it can be hard, right? I've got to convert from my traditional record storage where maybe I've got hundreds of tables, thousands, tens of thousands of columns, and we're saying, hey, take all of that complexity and stick it in an instances table, right? So converting this complex web of data, tables and columns and so on, into data agnostic record storage can be hard. You've got to figure out the XML to JSON formatting. You've got to be able to take the data that's in these hundreds of tables with different row formats and be able to convert that into a simple XML fragment. You've got to be able to figure out all of the relationships between the records. You need to be able to map the primary keys from the original systems into instance GUIDs in the new data agnostic record storage. You've got to be able to figure out the parent-child hierarchies by figuring out, well, okay, this customer record is a foreign key as in an orders table. So how do we reconcile all of that stuff? And then we've got to be able to deal with the record crosslink. So for example, in the orders table, I might have an order line, which is a child of an order, which is a child of a customer. But on the order line, I've got a reference to a product, which is a cross-record link to my products table. So all of this stuff needs to be converted, needs to be reconciled, needs to be made sure that it's complete and consistent. So that in and of itself can be hard, right? But there is a pattern, right? There is a pattern that we can adopt here. So the good news is that, you know what, we can leverage our user experience data model because we know what a customer is, because we have a definition of here is the customer concept, here's how the users interrelate that, here's what all of the fields on the customer object are, here's what an order concept looks like, here's all of the fields on the order concept and how they interrelate, and so on. So we can use our user experience data models to auto-generate most of the code that we're going to need to build our migration tables and our validation and processing code. And what this allows us to do is use a simple common pattern that we know is going to work and then focus the developer's attention on the bits that need to be customized. So the very specific business rules that will need some very specific code and logic to check that this value is in this range and this value corresponds to this value over here, which is corresponding to this value over there. If we can get, again, the majority of our T-SQL and code auto-generated, then all we need to do is focus attention on the few bits that really do need to be customized on this particular data migration. And then the whole point of using a standardized framework is that it provides consistency and quality to the import process. And this is great because what this enables us to do is that we can build this process for, say, an initial migration of customers and orders and order lines, part of our initial data loading process. But because we have now built that migration table and the T-SQL that's actually going to go through and process those business rules and logic and format it, then we can apply that code not only during the initial migration, but if we also then have subsequent bulk loads of customer or order information coming from other external systems. So essentially it works great for when we're loading the stuff in the first place, but we can then immediately reuse that to deal with ETLs and batches that are coming in on a regular basis. And this also works across multiple sources, right? So for example, if I've got a list of customers and orders coming from 4 or 5 different applications, as long as I'm putting all of that data into the same set of migration tables and applying the same business rules across that, then I don't need to worry about having a set of migration processes for application A and a different set of processes for application B and another one for application C and trying to keep them all in sync. All I do is say, well, application A, B, C, and D, we're going to put all of our information into our migration data table, our decoupling table, and then from that point, all of the code that then actually validates it, maps it, and loads it is actually the same across all sources. Once we've got this approach working, then we can apply this across all of the concepts and tables in a standard framework. And what that then enables us to do is automate the migration process itself. So instead of basically having to run one set of T-SQL to load our customers and then check everything's okay and then go and write a different set of T-SQL to load our orders and then go and run that manually and check everything works and then go and have a different set of T-SQL that's basically loading our order lines and run that manually and figure out what's going on. Because we're doing it the same way across all of the different concepts and tables, we can basically set up an automated process that's going to run through each of the sets of tables in order with a full set of automation control and automated rollback if the thing failed. What we do as part of using this approach is that we've saved a ton of effort in terms of auto-generating the code in the first place. We've increased the quality of that migration process, and we've also automated that process across all of the tables and data sets that are going to get fed in so that we can then make sure that we've got a standardized process for bringing bulk data into our solutions on a regular basis.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.